So here today we are going to be see what is a RAG. RAG is nothing but the retrieval augmented generation. So retrieval is nothing but seeking the relevant information from the source or a given query. Like examples, the relevant passages of the Wikipedia text or the database which given the question. Uh, so these are the things. Augmented is relevant or retrieved information to modify the input to a generative model. Example as an LLM. Okay, so generating an output which whatever the given input. So for example, in the case of the LLM, generate the passage text and given the prompt. Okay, so here the traditional MLM. So what is the traditional LLM models and what is the RAG model? Traditional LLM models are nothing but whenever the user give any prompt in the GPT, chat GPT, so it will give the response whether it is a correct or wrong. So it will give the response. A RAG based system, which is nothing but when user gives a query, what the model will do, it will retrieval. Okay, it will check everything whether it is a correct information, and the data store which is in the vector database, it will convert that, and whether it will give the text plus query to the LLM model, then it finally generate the response. So it will give the accurate and appropriate responses in RAG based system. With in traditional LLM model, it will just give the response whether it is we are not sure whether it is correct or wrong. Okay. So here it is. What kind of problems can RAG use for? So we have a customer support question answers chat and email chain analysis and a company internal documentation chat as well as the textbook question answers. Okay. So how we have to be train the model again to up to date data. Okay, so traditional LLM generative model, which we have given the prompt and generate, it gives the response, and which are nothing but LLM models are GPT, Gemini, and Llama 3. Okay, so here this is okay how we have to be connect to the database with the latest data. So here when the user gives the prompt, it will go to the LLM and it will convert to the vector database, that data retrieval from the vector DB database, and gives the relevant information to the LLM, and LLM response gives the response to the user. So this is how it will work. And user vector store, how this will work, it will give the user gives the prompt and data retrieval where it will store in the vector db and get what is the exact information and relevant data gives to the LLM, and finally it gives a response to the user. Okay, so this is the architecture. Based on this, so we are going to be build the our model RAG architecture. Here, the data preparation, raw data sources. Here, the data which we have given, and information extract in the backend. How it will extract the information like PDF extraction, web crawlers, etc. Chunking. It is nothing but the uh, data blocks. Okay. Now it goes to the embedding. Embedding is nothing but the it will uh, change the text data and vector database. It's stored in the vector database and it goes to the relevant database. And here when it's stored in the vector database, the user gives the query and it will again changes to the embedding and search in the vector database and give the relevant data to the LLM, and LLM finally gives the response. Okay, so how does this RAG work? So if it is as it is like the same thing which we have seen in the RAG architecture, how does it works? So let me just go to my collab. Here I have executed. So first we have to be why we are running this RAG model in the Google Colab, because we will get the 15 GB runtime here. Once you go to the change runtime TP4 and save, so we will get the GPU 15 GB data free. So it is easy to run our uh, code in Google Colab. So let me just go ahead and run this. So it's saying that it is already satisfied. Now pip install LangChain grok. So here we have the grok.com. Okay, so where you can generate your API key from the grok.com. So I have already done this and using this one. So let me just go and explain this. Here I have already pasted the my grok API key. So let me go ahead and run this. You can take any PDF here, and let me go and save this PDF to my local file, and it generates the response. So by default it will take the English language. It's not a problem, and now it is loading the document. Here you can uh, see where is this. Okay, so here we have taken the raw data source and the extraction is completed. Now let me go to here and uh, uninstall install unstructured data. So it is done. Now document loader. So it loads the document now, loading the information. Here extracting, which is nothing but the loading the information. It is done. Now let me go to the splitter. It is so created the file size, chunk size 15, chunk overlap 50. Okay, so the this one you can see here how this chunking will work and how the data will get splitted. Okay, so now here text splitter and text splitter documents. Here type of the data, we have a text, and so it is a list type and text data. So length of the text is nothing but the 137. The text Python inbuilt function PDF. Okay, so now embedding Hugging Face. We have using the Hugging Face embeddings. Here you can see this one. Okay, so chunking is done. Now embedding. After that, it will store it in the vector DB. Then we can give the our query. Now let me go to here. So it is storing the persist directory vector DB. It is finally stored in the vector DB. Now we are just uh, asking to print that vector DB. Now vector DB documentation embedding is perfectly done, as we can see here. Okay, it is stored in the vector DB. Now embedding, and it is converted into the vector DB. Now let me go to my code and print vector DB is done. Now retrieval. Now I'm selecting the one model, which is nothing but the Gemma 2 9BIT. Okay, so you can select any model from the grok.com which is available. Okay, so retrieval question answer stub and return source document is equal to true. Now query. So I'm asking explain about the filter map reduce. Okay, so here you have given the query. Now it is stored into the vector DB. You can see here it is stored in the vector database. Now you can ask any question what is the AI ML, what type of models we can use in AI or ML. So what is the RAG models, and what is the LangSmith. You can ask LangGraph, so it will give the response here. So I have asked the question as explain about the filter map and reduce. So it generated the response. Now here it is the explanation about the filter map reduce, and now it give me the response. It printed here. So you can also how does it works, you can check all these things. Now here I have given another question, another query. What are the functions from this PDF? The above PDF which I mentioned here. So I'm asking to explain about this PDF. You can, so this is nothing but the PDF. You can include any PDF which is related to the. So here it is the PDF. This is just an image format type I have given for the time sake purpose. Now let me go here and I have given the two queries here. So it is already done explain about the filter map reduce and it given the response to me. Now I'm asking the another question, what are the functions from this PDF? Okay, so I'm asking to print the response. It give the response. Now finally I'm asking to print that result. So it print the result and query here. What are the float format, everything, the functions which we have used, it has given. Now I'm asking the same thing it has given. Now source PDF. What is the source of the PDF? Python inbuilt functions.pdf. Now I'm asking to give the response for the users. Finally, it gives the response to the user. Here you can see. So it is asking the query. We have given the query and it converted it to the text and checked into the vector database and it retrieves the relevant information, appropriate information, and it gives to the LLM. Finally, it gives the response to our model. So this is how the RAG model will work, and this is nothing but a RAG architecture. That's it for today. Thank you.